Today we're going to discuss slope and elasticity. These are two similar concepts that students tend to get confused with one another. So this supplemental lecture is meant to overcome some of those confusions. So without further ado, allow me to share my screen. So slope and elasticity. The important takeaway here is slope is not the same as elasticity. Slope and elasticity are related concepts, but they are fundamentally different. Slope refers to the shape and steepness of the line of the function we're looking at, whereas elasticity refers to percent changes along the line. In order to see this difference more clearly, we need to dig into a little mathematics. Recall from your intro geometry classes that the slope of a line is the rise over run, or the change in the y variable over the change in the x variable. Recall from our earlier lectures that elasticity, which I am representing here by this Greek letter eta, is the percentage change in quantity divided by the percentage change in price. The Greek letter delta here is often used to refer to a change. Furthermore, recall that price is our y-axis and q is our x-axis variables, respectively. Thus, we can rewrite elasticity as the percent change in the x variable divided by the percent change in the y variable. So we can already start to see what is going on here. The slope is the change in y over the change in x. Elasticity is a change in x over the change in y. We're also dealing with percentages here. This is going to become very important in just a few moments. Before we get there, elasticity and slope do have a relationship. Slope can tell us whether or not we're looking at a demand curve or a supply curve. If slope is negative, chances are we're looking at a demand curve, although we can have downward sloping supply curves as well. If the slope is positive, then we likely have a supply curve. It is theoretically possible to have an upward sloping demand curve, but empirically, those do not seem to exist. So slope can tell us whether we have a supply or demand curve. Elasticity tells us the relationship between price and the quantity. So let's take a look at a little mathematical example that will show that slope and elasticity are not the same. Here we have just a regular demand curve, a basic demand curve. It is linear, it's a straight line, meaning that the slope is going to be the same everywhere. So if we look at the table, this table represents the the demand schedule with price on the y-axis, quantity on the x-axis, and the slope at each point is -1. It's a line, it's a straight slope, flat, or the slope is the same at every point. However, the elasticity changes. Up here in the higher parts of the demand curve, where price is relatively high, we have a relatively elastic demand. Whereas down here, where price is relatively low, we have a relatively inelastic demand, as you can see. And there is one point when price is changing from 6 to 4, so over this portion here, where the elasticity is unilastic. So when you have a linear line like this, the slope is the same, but elasticity is going to vary from point to point because elasticity is a percentage change, not the change of the variables themselves. So let's look at the two extremes. This is a response to 2 questions asked at the end of chapter 5 in our OpenStax textbook. First, we have a perfectly inelastic demand curve, or demand in this case. You can also have a perfectly inelastic supply curve. What is the slope and the elasticity here? Elasticity, again represented by eta, is the percent change in quantity over the percent change in price. The percent change in quantity is zero. Quantity does not change regardless of the price. Percent change in price can be infinity. It can go as high as it wants, essentially. Really, infinity here is just meant to mean some arbitrary number. The logic doesn't change if we make this, if we change this infinity to something else at all. Because anything divided by, or 0 divided by anything is going to be 0. There is no elasticity here, 0 elasticity. However, the slope is undefined because it is infinity divided by 0. It's the change, it's the change of price over the change in quantity. Change of price can be infinite or arbitrary. Change in quantity is always going to be 0. That gives us an undefined slope. A vertical line is an undefined slope. So with perfectly inelastic, it has 0 elasticity, but a slope that is undefined. For perfectly elastic demand or perfectly elastic supply, the opposite is true. Elasticity, eta, is an infinite change, percent change in quantity over no change in price. So we get really an undefined or infinite supply, or elasticity of supply, elasticity of demand. Whereas the slope here is 0. Just like in the other example, it's your change in price, which is 0, your change in quantity, which can be infinity, 0 divided by infinity, 0 divided by anything is going to be 0. So something with inelastic demand, inelastic supply, will have an elasticity of 0, but an undefined slope. The opposite is true for perfectly elastic supply, perfectly elastic demand.